Assalamu alaikum Hamagil. Welcome everybody to GDG Samarkand welcome event. My name is Azimjon. I'm a software engineer at Super Dispatch. I work mainly in backend development, and you can follow me on Twitter at AzimjonDev. So today I've prepared a really good topic called Programmable Google Assistant. And today we'll be discussing some of the topics that you might encounter while programming your own Google Assistant. So before we get started, I would ask you to unmute your Google Home devices if you have any, for example, Google Home or Google Nest, because I will be saying the word, "Hey Google," a lot. And the next thing is, if you have any questions at any time, leave it in the message box. I'll be able to answer all of your questions at the end of the session. All right, let's get started. So let's define what a smart means. We have seen smartphones, we have seen smartwatches, we are seeing smart fridges, and we have seen smart TVs, right? What makes devices smart? According to my experience, if a device has capability to enter a specific website or be able to do more than it usually does, for example, a watch can not only show a watch, but show you calendar events, can show you heartbeats and weather, it's a smartwatch, right? So that's what the definition of a smart thing is. So over the years, we have seen devices to become smarter and smarter day by day. And a lot of you may not know that smart speakers exist too. And smart speakers are becoming popular day by day. So for example, there's Google Nest, used to be called Google Home, now it's called Nest. And there's Amazon Echo, and Apple HomePod was introduced this year. So all of them are powered by a software. So for example, Amazon Echo has Alexa inside, and Google Nest has Google Assistant, and Apple HomePod has Siri inside. All of those software makes those speakers smart. They can answer any questions you have on the internet, and they are very smart. They can do things for you, for your home. So you can automate your home and get things done with audio, with voice commands. And among all of those, Google Assistant is by far the most popular one. It's everywhere. It's on your Android phones, it's on your tablets, it's on your TVs, it's on your car, it's on your watch, it's everywhere. So whenever you make any app for Google Assistant, it automatically becomes available for all of those platforms, which is fascinating, which is great for developers. So you don't have to code for every one of those devices. You just built one app for Google Assistant, and it will magically become available for all of this. And so this is me. This was last summer. So I participated in Google Cloud Study Jam Challenge, and because I finished all of those challenges in time, I got a gift from Google, which was Google Home. And the day I got my Google Home in my hand, I wanted to make some tweaks. Because I'm a programmer, I want to tweak things. I want to make something special out of it, because I don't want to have something that everybody has. I want to have custom Google Home. That I discovered this service called IFTTT. IFTTT stands for if this, then that. You can integrate any apps together. You can bring any apps together, and it has triggers and actions. You can trigger at any point of view and then have actions alongside with it. So to be able to explain this to you, so let's take a look at what Google Assistant has to offer in IFTTT. So in Google Assistant section, you can see that you can program your Google Assistant without any lines of code to say things that you want to hear back. For example, if I ask Google a question, I want a specific answer for that. I want to hard code some of the responses of Google Assistant. I can do it with IFTTT. So before you do that, you need to connect your Google account to IFTTT. When you click connect, it will ask redirect to Google. It will ask you to give permission IFTTT to manage your voice commands. This is very strong permission. It means that IFTTT will be able to listen all of your voice commands that Google Assistant, you're saying to Google Assistant, and which is something you wouldn't actually want to give it away. So, but I trust IFTTT and I give it voice commands permission. So once your connection is done, now you can add custom request response behaviors for IFTTT. So if you ask who is the best or who is the best from Google Assistant, it should respond was you're the best, Azimjon, right? This is what we expect. So let's take a look at a demo. So I'm gonna play a demo I recorded earlier. So the same demo that's been made by IFTTT. So let's take a look. So I see it's muted now. I'm gonna unmute and start again.
Hey Google, who's the best?
You're the best, Azimjon.
Ha ha.
Ha ha ha.
I hope you could hear it. Even if you didn't, it's okay. I asked Google Assistant to say, I asked the question, who is the best? The answer was, oh, you're the best, Azimjon. It usually response was, you are, but I completed the sentence for myself. I made a custom response for Google Assistant, which is very easy. As you see, like we did nothing. We just added one line of trigger. That was all of it. The other part of IFTTT applets is that you can add actions. Whenever a trigger happens, you can add actions to it, corresponding actions. And those actions are usually triggered by some kind of trigger. For example, in this case, it was a voice command. Whenever you say something to Google Assistant, it can trigger things. My favorite trigger is webhook because it allows me to add my own custom ideas. For example, if I say, hey, Google, tweet this, it will be able to grasp the tweet and then give it to action. For example, a webhook. And from webhook, I can take it and post a tweet from my own account. So possibilities are only limited by your imagination. So you can do anything from Google Assistant using webhooks. And let me check if you could hear me or not. So I hope you could hear the demo because I'm going to show another video from Silicon Valley. If you have watched Silicon Valley series season 5, there's a cool app that Guilfoyle makes in order to make to hear alerts from whenever Bitcoin price changes. Let's take a look.
It's an alert. Whenever the price of Bitcoin dips below a certain value, it's no longer efficient to mine. When it comes back up, it is. So I need to know when it breaks that threshold so that I can remotely toggle my rig at home.
Any idea how often that might happen?
Bitcoin is very volatile, so...
This is so loud.
A lot.
Good. All right, well, maybe turn it down or something.
This app was fascinating. It was a great example of programming your own IoT devices. So with that in mind, I decided to re-implement the same idea behind Bitcoin Alert. So whenever the Bitcoin price is below some threshold of price, I can play alerts on Google Home. So Google Home has a specific kind of technology called Chromecast. Chromecast is allows devices to play media between each other, so that any device connected to the same Wi-Fi will be able to play media. For example, my phone or my Raspberry Pi or my MacBook will be able to play media on my Google Home using Chromecast technology. And in Python, there's a very good package called PyChromecast. You can get the Chromecast, and I'm using Zero's Chromecast because I have only one Chromecast. If you have many, you can iterate over all of the Chromecasts and find the one you need by the name. And then you need to call .wait in order to wait until the connection has been made. Once a connection has been made, you can go through the playing audio on the Google Chromecast. So I deployed this app onto my Raspberry Pi, which was $5 computer, a very small computer. You can plug it into a power adapter or a power bank and then use it for weeks. So, but I'm not really a Bitcoin person. I'm not really interested in Bitcoin price changes, but I'm interested in the build pipelines. So whenever my test fails, I need to be alerted. That's why I built a version that would play the same alert. Guilfoyle has has for Bitcoin alerts for my test failures. So whenever I push code and it fails in the cloud, I get alerts, because sometimes tests take about 10 minutes and I can't wait, but I have to be alerted when it fails. That's why I make use of this code and deploy it to the Raspberry Pi. I use Spotify a lot with Google Home, because Google Assistant can be integrated with many applications alongside with Google Spotify. So I usually listen to songs which I want to listen while cooking, while doing some extra work, while cleaning. So that's why I encountered this bug a lot. Spotify never plays the songs I want, because in the premium version, you can't play songs you want. So let me give you some example, a demo. So,
Hey Google, play Taylor Swift on Spotify.
Here's a Spotify station featuring Taylor Swift.
It's just another night, and I'm staring at the moon.
as you could see, that Spotify never plays the songs you want. I asked Taylor Swift, it played Ed Sheeran, which is not fair, which is something you never want, because it's a smart speaker, but it's becoming dummier and dummier if you don't pay the price for a premium subscription. And I decided to change it. I decided to play the songs I want for free. That's why I remembered about 2 years ago in a hackathon called Garage 48, with a team of 4, we built a music engine, music searching engine. So it was called Music Spider. Spiders would go through different websites and gather along different songs from the internet, and we could play songs right in the browser. But this time, I pulled up the song part and integrated with the Google Home. And so here's a demo, another demo, so how Music Spider works. And you can take a look how smart it is.
Hey Google, talk to Music Spider.
Okay, let's get the test version of Music Spider.
Welcome to Music Spider. What would you like to listen?
Play Rick Astley.
Playing Rick Astley from Music Spider.
All right, as you could see, it's playing the song I want, and it has millions of songs in the database, and it can play any song I want. And in the rest of the talk, I'll be explaining you how I built a Music Spider application for Google Assistant. So there are multiple ways you can add new features, extend the features of Google Assistant. One of the ways is to use Google Actions. And another way is to use Dialogflow. Dialogflow is another way you can integrate, extend the features of Google Assistant. But I use Actions a lot because Actions is more of a standard in terms of adding new functionalities to Google Assistant. And so I'm not going to go through everything in detail. So I would highly recommend going to YouTube and searching for Behind the Actions tutorial. It's done by Google developers, and you'll love it, because I used it while learning about Google Actions. Google Actions is great. So once you create a project in Google Actions, what you're gonna see is this screen, and it shows you a main invocation. So your app needs to have an invocation. For example, in my case, it was I talked to Music Spider. I asked Google Assistant to talk to Music Spider, and it pulled out a test version of Music Spider application, and noticed that it only works for me because it's under my account. So until I deploy the application, it won't be available to anyone else. So it's only available to yourself. That's why it's a test version. So, and then after the main invocation, there are some intents. Like intents are like users' intents, what they want to do with your application. You can add multiple intents. For example, if you're asking yes/no questions, intents can be yes and no. What user can mean, right? And there are multiple ways of saying yes. For example, user can say yes, yep, or sure, or of course. There are millions ways you can intend, like yes, the same for no. Or if you're building an application for an alarm, you can have intent for adding an alarm. For example, you can say wake me up at this point, right? So all of them are intents. So when you're making applications, you need to add training vocabulary for your intents. Intents are great. So before adding any functionality to your application, you may want to start with intents, because what user can say and mean. Another thing is types. So types are everywhere in programming languages, right? And the same was Google Assistant. So you can add types. There are system types. For example, a date, a number, or time. There are built-in types. But if you want to extend and add a new type, you may want to add a new type. For example, for Music Spider, I wanted to add a new type called song. Song, we can't define song because songs is a free text. That's why I added the free text for type of song. But if you're dealing with passport numbers or driver's license numbers, you may want to go with regular expressions. So why do you need types? Because Google Assistant will validate those types for you. So until user enters something valid, Google Assistant will keep asking it from the user, which is great. You don't have to do error handling yourself. And you can add new types. For example, if you want to add color type, you can add word synonym types. For colors, you should add all of the colors and then define as type color. And then whenever user adds a type, it will be a valid color, right? So everything comes together in scenes. Scenes are UIs, but it's not visible because it's a Google Assistant. Scenes are like steps of the application. For example, whenever my application gets invoked, my application, for example, Music Spider, would ask user for a song. So that's why slot filling, you can see here that it's asking for a song. And then I can add validations for songs, for example. And then whenever slot status becomes final, it means whenever user enters a song, what it will do is call my webhook. Because whenever you want something static, you can type it here. But if you want something dynamic, you may want to use webhooks. Webhooks are a great way to make your applications dynamic. So it will request to your webhook API, and then it will take a response and give it back to the user. For example, in this case, whenever user enters a song name, for example, a Taylor Swift or Rick Astley, it will call my webhook, and from my webhook, I'll take the query, whatever user has set, and I'm going to search the song, and I'm going to return a media response. Media response is like a media object inside, and it has a playable URL, audio file. So how do you define webhooks? It's easy. You go to a webhook section, and you need to add a publicly available URL, which needs to be HTTPS. Webhooks are hard things to debug. If you want to have HTTPS and public available URL, you may want to deploy it somewhere. But with JPRQ, some application that I've built earlier this year, you can have public HTTPS URLs for your web servers right in your computer. For example, when you type JPRQ, when you install JPRQ and type JPRQ 5000-S Music Spider, it's going to take the subdomain of Music Spider, and it's going to make a tunnel between your server and a public server, and tunnel between them, and it will expose your port 5000. So whenever someone, for example, Google Assistant will make a request to this public URL, your local server will receive it and process it and respond it, which is very handy way of dealing with webhooks. Webhooks are great, so be sure to check out JPRQ because it's becoming popular, more popular than NGRock that was before available. But NGRock has so many like disabilities because you can't really take a custom subdomain. It has limitations. That's why JPRQ is becoming more popular. So how do you publish your application. Once you're done, your application is working for Google Assistant. What you want to do is to publish your application so that your friends, your family, everyone you know wants to use it, right? So it's a little harder. I found it a little harder to publish your application because it's asking a lot of information. For example, information about the company, information about the images, description, everything that you may want to add for an app, for Android app, for publishing Android app. So you need to add privacy policy, which is where I am stuck right now. So you need to be able to come up with a privacy policy, what you're using for user information, and then you'll be able to publish your application. So I haven't published Music Spider yet, but stay tuned. I will publish it soon. And Music Spider, the webhooks I mentioned earlier about taking user's query and then turning a media response is right here in this GitHub repository. I made it public so that you can see it. Check out the source code. It's in Python and written in Flask. So and there's a Spider section which is searching songs from the internet. So be sure to check out. It's something fun. You can play with it. You can play with the Spider part. You can play with the server part using JPRQ, exposing your port, and then adding new functionalities to your Google Assistant. So thank you very much. So the presentation is available through this URL, bit.ly Programmable Google Assistant. If you have any questions, I'll be able to answering all of your questions now. Thank you very much.